of showing you how to go through it, because most of our cases are with the undiagnosed disease program. So I have a family, I have a mom and a dad and a sick child, so I have a proband. Sometimes I have their siblings, sometimes I have their uncles and aunts, grandparents, and so you want to be able to in Excel. They're tab delimited, so make sure you know that they're tab delimited. If you don't say it, then everything gets all squished together. But like I mentioned at the early morning, you've got several, you can have anywhere from, a couple to several hundred rows of just information. What does each of these little QD, MQR, rank sum, MQM, leave, so forth, all stand underneath this info tab. And then here you get into the meat of the actual VCF file. And so here you've got your chromosome position, your ID, reference, alternate, and so forth. And at each position, in each row is a variant. And so like in this one at chromosome 20 at this position, it does have a DB SNP ID number, that's this RS number. You get a reference allele, which was the C, but it was seen as a T. And then you get into this info column. And this info column can be very long and based off of all the various little acronyms that are in the above rows to get a feel for that. And then, like in this instance, this patient is homozygous for this variant because of the 1/1. Now, if I had done phasing instead of that slash, I would have seen a pipe, and then would have, so forth. But in this instance, I'm just looking at a particular variant here, and I think most of these are all homozygous for the patient when I was just extracting out a smaller subset to play with. And so, as you can see, if I go back to this info tab, you have no information about what this particular, where this is at, what gene is it in, what type of mutation is this. And so what you need to do is to go back and where did my Word document go? There it is. And annotate these variant files. So you take this VCF file and you load it into one of the many tools that are out there. SNPF is one I sort of mentioned in these documents, but don't forget there's Anavar, there's VEP, which is from Ensemble, which I'm leaning more into just because I like how Ensemble works nowadays. I used to hate Ensemble, but now it makes sense now. So when you have a VCF file, you're going to want to run some sort of effect on function, and so we're going to just mention SNPF here. And so at the command line, you all can sit back, you don't have to do any typing in here, so just watch. And apply, because I know the blinking cursor can scare the living daylights out of some people. I mean, it's just sitting there saying, hey, give me something, give me something, give me something, So anyway, so you can apply this to your own data set. So SNPF is a jar file, so it's a Java application. And so when you call these Java tools, you have to call Java at the command line. And so if you were sitting there on the command line on your Unix box or your Linux box, and you had SNPF installed, you would call in Java. I was telling it that I only needed so much RAM, because I didn't want to overburden my virtual machine, because it can use a lot of RAM. And then I pointed to the path of where I had installed SNPF on my machine. And so here I have where it is. It's in the tools folder under the SNPF directory, and then this is the jar file I'm calling. Then I'm giving it, I want to come back with some sort of HTML file. So I wanted to create a sort of a summary of what did SNPF find, and I'll show you what that summary file looks like. And then you get to tell it, well, what version of the human genome I'm using. And so that, remember this morning I sort of went on to a lengthy description of what, make sure you know what versions you have, because at the end of the day, SNPF only has certain of these versions of the human genome. So you don't want to go and align to 37.64 because it might not be in SNPF. And then you have to come back and find 37.75 or whatever. This is the latest. This was the last HG19 one that SNPF created, and now they go into the GRCH38. Okay, and then you feed it the VCF file that you're interested in. So whatever VCF file you have at the end of the day, you give it that. And then I have this output, And I'm just telling it, I'm giving it an extra extension of SNP before, just so I know. And you can see I'm outputting it as another VCF file. And so what you get here, and let me also explain one thing too here, is that I have all these lines of these commands and these parameters all sort of broken down line by line. And so really, at the end of the day, this command, you could copy and paste it, but it really looks just like this. It's one gigantic line of code. And so that is the entire command that you would type to have SNP run. But what you see is I had these backslashes here, and that allows you on command line to sort of break it down into rows and sort of be able to see things a little better, especially when you're writing a bunch of code. It just sort of says, hey, I'm not yet done, go to the next line. There's more parameters and options that I'm telling it. And then you'll notice that the very last line does not have that backslash. So it's basically saying end, and that's my entire code. So just an FYI, when you see me have these backslashes, it's just for easier viewing for you. And you need to include those if you're going to write it line by line. You need to make sure you keep those backslashes there. Okay, so at the end of the day, when you run this command here, you're going to generate an HTML file, and you're going to generate a VCF file that will have annotations. And let me open up. And so over here is this HTML file that SNP creates, telling you the command that you ran, but then also it sort of breaks things down. This data set is only looking at a very, very small region of chromosome 20, and so here you only see that there, you have chromosome 20 here. If you had the entire genome, you should see 1 through 20 through 2 in the autosomal chromosomes, and the other chromosomes that don't have yet a home in the main ones. But here you'll see that there were 55 SNPs, 3 insertions, 6 deletions. A majority of them in this example were intron variants, a nice table, a nice bar graph that shows you where things were.
Question on this, why you put 2 exon, one on the left, one on the right?
I'm sorry, what now?
On the figure, you have 2 exon?
I have 2.
Like with the figure, when he put the figure?
Yeah,
Why
so
you
this is
put
all
this?
generated by SNP.
I know why you put the,
I don't know.
Why you not just
I'm not
one?
Pablo.
Oh,
Who wrote
okay.
SNP.
But you have the-
But that's what he's done. So,
Yeah.
yeah. I very rarely look at the changes and so forth. That is what the summary report. If you look at the that VCF file here, let me open it up. So if you come in here and then now look at this file that was generated, I gotta find it. Okay, so let me open up the file. This one. It's delimited. So now it looks similar. You're sort of going, oh, I don't see any changes here. But if I go inside my info tab here, you'll start to see now there's a lot more information here. This is now telling me here is the SNP output that's inside. I'm trying to make this bigger so I can show you. So here it's telling me that it's in this particular gene, the SNP25AS1. Here's the ensemble identifier. It's a transcript. This is the ensemble transcript, and it's an antisense mutation. So it's at this position, a G to an A, so forth. And why do you see this repeated multiple times, this SNP25AS1, SNP25AS1? Again, you see it at least